Hello everyone, welcome to NEET Physics Decode. On this channel, we'll be learning physics for NEET in a simple and exam-oriented way. In this series, we will cover complete theory, important concepts, and NEET level questions to help you score better in the exam. So without wasting any time, let's begin our first chapter, which is units and measurement. Starting with the International System of Units, there are three systems given in NCERT. The first being your CGS system, which includes centimeter, gram, and second. The next system being your NKS system, which includes meter, kilogram, and second. And the third being your FPS, which is foot, pound, and second. But currently the most widely accepted system is your SI unit. Moving further, we have physical quantity. Physical quantity is basically the quantities which can be measured by an instrument. A physical quantity has two parts. One being its numerical value, which is represented by n, and the second being its unit. Numerical value, and the second being its unit. Numerical value is basically the number of times a unit occurs, whereas unit is basically used as a comparison type. Moving on to the types of physical quantity, they are divided into three. First being your fundamental, second is your derived, and third is your supplementary, which comes under fundamental. Okay, so starting with your fundamental physical quantities that I've written over here, there are 7: length, mass, time, temperature, electric current, luminous intensity, and amount of substance. You all might know the units. Length, SI unit is meter, mass is kilogram, time is second, temperature Kelvin, electric current ampere, luminous intensity candela, and amount of substance mole. I've written the symbols over here, you can refer it later in the video. Moving on to derived. So derived are basically which are made up of fundamental physical quantities. So let's say for example we have area, which is your length times breadth, that is your meter into meter, which is your meter square. Now let's take another example, velocity, which is distance per unit time. So these two are examples of derived physical quantities. And last but not least is supplementary physical quantity, which includes two. One being your plane angle and other being your solid angle. Theta is basically your arc upon radius. Plane angle has a unit called radian, whereas solid angle has a unit called steradian. The important thing to remember in this is that supplementary physical quantity have units. They have units but no dimensions. This is an important thing to note. If you want to represent it, a plane angle can be represented as this. This is your arc, this being your radius, and this is the angle theta. And for solid angle, this theta. Okay. So on this slide, revising everything in short, we saw about the three international system of units, and the most widely accepted being your SI unit. Then we saw what a physical quantity is. They have two parts, numerical value and a unit. Then we saw the three types of physical quantity: fundamental, derived, and supplementary. Moving on to the next page, which is your significant figures. This is frequently asked in NEET. Basic rules that you need to keep in mind to understand significant figures. Starting with rule number 1. All non-zero digits are significant. All non-zero digits are significant. Let's say for example, if we take a number, let's say 34.5. So you can see all the digits are non-zero. The number of significant figures will be 3. Let's take another example. 44.65. So number of non-zero digits are 4. So 4 significant figures. Next rule, all the trapped zeros or the one which appear between two non-zero digits are significant. All the trapped zeros, trapped in the sense which are in between the significant figures, or you could say non-zero digits, significant figures or non-zero are significant. Let's say for example you have 6.02. So you can see 0 lies between two non-zero digits, 6 and 2. So the number of significant figures will be 3. Let's take another example, 12.005. You can see these two digits lie between non-zero digits 2 and 5. So the number of significant figures will be 1, 2, 3, 4, 5. 5 significant figures. Let me write this 5 properly. 5. Moving on to the third rule. The third rule says initial zeros are always insignificant. Initial zeros are always insignificant. Like let's say for example we have 0.52. The 0 is initial over here. The number of significant figures will be 2. Let's take another example, 0.0061. All these zeros are initial, so the number of significant figures will be 1 and 2. 2 significant figures. Moving on to the fourth rule, which is ending zeros are significant if placed after the decimal. Ending zeros are significant if placed after decimal. If placed after decimal. Let's say for example 4.670. So you can see the 0 appears after the decimal point. So this will be considered as significant figures. So number of significant figures will be 1, 2, 3, 4. So 4 significant figures. Moving on to the fifth rule, which is ending zeros without decimal are not significant. Ending zeros without decimal are not significant. Let's say for example 1600. These two zeros are coming before the decimal point, so the number of significant figures will only be 1 and 2. 2 significant figures. Let's take another example, let's say 360. So only 1 and 2. 2 significant figures. Sixth rule, which says order of magnitude is always insignificant. Order of magnitude is always insignificant. Like let's say for example we take a number 4.8 into 10 to the power 5. So this is considered insignificant. We only consider these two. So number of significant figures will be 2. 2 significant figures. Seventh rule, that constants have infinite significant figures. Constants have infinite significant figures. Like let's say for example speed of light. Speed of light, if you all know, represented by c, which is 3 into 10 to the power 8, will have infinite significant figures. Let's say refractive index. Refractive index is represented by mu. Let's say 1.5 will have infinite significant figures. One thing important to note is that number of significant figures don't change on changing the units. Like let's say for example 120 centimeter. If you want to convert this into meter, which would be 1.2 meters, both the numbers have the same number of significant figures. As you can see, 1, 2, this 0 will not be considered as significant figures because it comes before the decimal point. So two significant figures, यहाँ पे 1, 2, two significant figures. Okay, so now moving on to rules for rounding off and arithmetic operations. So here, if we talk about rounding off, let's take an example. Let's say you're given a question, round off to two significant figures. Let's say example number 1, 1.63. You can see 3 here is less than 5, so it will be rounded off to 1.6. Let's take another example, 3.57. As you can see, 7 here is greater than 5, so it will be rounded off to 3.6. Okay, now let's say we're given a number like, let's say 6.852. Now as you can see that here we have a 5. In this case, what you do is check the next digit after 5. As you can see, it's 2 over here. If it is a non-zero digit, then you increase the number. Okay, if it's a 5, then you increase the number if it is a non-digit. So this will come out to be 6.9. Now let's say if you have a digit after 5 which is 0. In this case, what will you do? Let's take a number like 4.650. As you can see, we have a 0 after 5. In this case, what you need to keep in mind is the number before 5, which is 6 over here. If the number before 5 is even, the number remains the same, and if it's odd, it will increase by 1. In this case, 6 being an even number, therefore it will be rounded off to 4.6 itself. Let's say if you would have taken a number like let's say 4.750. As you can see, the number before 5 is an odd number, therefore it will be rounded off to 4.8. Rules for arithmetic operations. Okay, so first rule is for addition and subtraction. This says that the result will be rounded off to the number having least number of decimal points or decimal places. Least number of decimal points or places. Let me explain you with an example. Let's say we have 1.2 plus 4.54 plus 6.652, which comes out to be 12.392. What the rule says is the result should be rounded off to the number having least number of decimal points. As you can see here, 1.2 has the least number of decimal places, which is only 1. So this would be rounded off to 12 point. As you can see, the number after 3 is 9, and 9 being greater than 5, this would be rounded off to 12.4. The next rule for multiplication and division. This says that the result will be rounded off to the number having least number of significant figures. For example, let's say 4.2 multiplied by 6.41. So as you can see here, the number of significant figures are 2. So whatever the result you get, you round it off to 2 significant figures. I think everything in this slide. We saw a few rules for significant figures, which is asked in NEET, so it's important that you memorize this rule and know how to apply it. Then we saw some rules for rounding off and arithmetic operations, which is addition and subtraction and multiplication and division. The important thing to note is during addition and subtraction, we see the decimal points or places, and in case of multiplication and division we see the least number of significant figures. Moving on to the next topic, different types of errors, starting with your absolute error, is basically the difference between true value and measured value. Okay, so let's say I take numbers like n1, n2, n3 and n4. Okay, so the mean of these numbers would be n1 plus n2 plus n3 plus n4 upon 4. So the absolute errors would be delta n1 is equals to the mod of the mean value minus the number. Similarly, delta n2 will be the mod of mean value minus n2 and so on. Moving to the next error, which is your mean absolute error. Mean absolute error, it's basically the arithmetic mean of the magnitudes of absolute error. Magnitudes of absolute errors. Okay, so delta n mean would be the mean value of delta n1 plus delta n2 plus delta n3 plus delta n4 and so on upon n. Okay, and the result would be written as n is equals to the mean value of n plus delta nm. Okay, moving on to the third error, which is a relative error. A relative error is basically the fraction of the mean absolute error upon the mean value, which is basically your mean value here and your delta n mean and this. Okay, and fourth being your percentage error, which is basically your relative error multiplied by 100. Moving on to proposition of errors, where we have addition and subtraction. Starting with addition and subtraction. Okay, let's say x is equals to a plus b and x is equals to a minus b. So delta x would be delta a plus delta b, and in this case delta x will still be delta a plus delta b. Okay, so even though during subtraction you will add the errors. Okay, let's say for example there's a question which says the initial temperature is given as 40.6 plus minus 0.2, 40.6 plus minus 0.2 degrees Celsius, and your final temperature being 78.3 plus minus 0.3 degrees Celsius, and they ask you calculate the rise in temperature. Calculate the rise in temperature. So what you do is 78.3 minus 40.6, which is 37.7, and what you do with the errors, as I told you over here, is basically adding them. So 0.3 plus 0.2 giving you 0.5. So your final answer should be 37.7 plus minus 0.5 degree Celsius. This was about addition and subtraction. If you talk about multiplication and division, multiplication and division. Let's say x is a into b and x is a upon b. So delta x by x would be delta a by a plus delta b by b. The same thing goes with division. Delta x by x is equal to delta a by a plus delta b by b. They even give you percentage, then do the same thing. Delta x by x percentage is equal to delta a by a percentage plus delta b by b percentage. Let me give you an example. Let's say they ask that calculate the area of a field if the length and breadth is given as 4 plus 0.4 meters and breadth being 2 plus 0.2 meters. Okay, so we all know area is length into breadth, so 4 into 2 will be 8. Now talking about the errors, we'll have to use this thing, which is delta a by a is delta l by l plus delta b by b. So here we need to find delta a. Area which we found out as 8 is equal to delta l by l plus delta b by b. 0.4 ones are 0.4 tens are. Delta a by 8 is 2 by 10, which is 16 by 10, 1.6. So area of the field will be 8 plus minus 1.6 meters. Okay. Next is quantities raised to some power. It is frequently asked in NEET. Okay. This is very important. Okay. So let's say x is a raised to p, b raised to q upon c raised to r, and they ask you what is delta x. So delta x by x will be equals to, you have to take the power over here and write it as p times delta a by a plus same thing over here q times delta b by b. Okay, and let's say there's something in the denominator, we'll still add it. Okay, not subtract, add it, plus r times delta c by c. Okay, you can do the same thing with percentage. Delta x by x percentage will be equals to p times delta a by a percentage plus q times delta b by b percentage plus r into delta c by c percentage. Okay, let me explain this with an example. Here's a question which was asked in NEET 2019, which says the percentage error occurred in the quantities A, B, C and D are 1%, 2%, 3% and 4%, and they ask what is the maximum percentage error in x, where x is equals to a square, b raised to half, c raised to 1/3 and d cube. Okay, so delta x by x percentage would be equals to 2 into 1 plus half into 2 plus 1/3 into 3 plus 3 into 4. These values will get cut, giving you 2 plus 1 plus 1 is 12, which comes out to be 16%. Okay, so summarizing everything on this slide, we saw about different kinds of error like absolute error, mean absolute error, relative error, percentage error. Then we saw about propagation of errors in addition and subtraction and multiplication and division, where in addition and subtraction, in the case of subtraction, the errors will still get added, and here delta x by x will be delta a by a plus delta b by b. And then we saw quantities raised to some power, which is very important and it's very easy. If you have already studied in a class, you'll already be knowing this. It's very easy, and the questions are also not very tough. Okay, moving on to the next slide. Dimensional analysis. So dimensional analysis is basically the powers raised to the fundamental units to the fundamental units. The most common one being your length, mass, and time. Okay. Let's say for example we take speed or velocity, which we all know is distance upon time. So distance, which is length, time, t. So the dimensional formula will be written as, there's no term of mass, so m0 l1, and time being the denominator will be written as t minus y. Okay, now let's say we take acceleration. So acceleration, we all know, is speed or velocity upon time. So L upon t, another term of t, so m0 l1 t minus 2. Similarly, you can find force, work done, energy, etc. I'll just tell you in short. Force, we all know, is mass times acceleration, so it will be m1, and the same as acceleration, l1 t minus 2, and work done, which is force times displacement, so there will be another term of L, so m1 l2 t minus 2. Okay, moving on to principle of homogeneity. Principle of homogeneity states that similar physical quantities are added or subtracted. Okay, let's say for example here v is velocity. Okay, so velocity is alpha plus beta t. So what does the principle state? That similar physical quantities will be added or subtracted, which means alpha will have the same physical quantity as that of velocity. So alpha, which is itself velocity, will have the dimensional formula L1 t minus 1. The same thing over here. Beta t will have the same physical quantity or the same thing as velocity. So beta into t is equals to L1 t minus 1. Beta is L1 t minus 1 upon t, which is L1 t minus 2. Okay, some things which we need to keep in mind is that some expressions, they do not have any dimensions, like let's say for example e raised to x or any number raised to x. Here x will have no dimensions. Similarly, anything which is enclosed in log, let's say log x or let's say log y, here x and y will not have any dimension. Similarly, sine, theta, or anything like tan y, any angles will not have any dimension, they are dimensionless. So theta and y over here are dimensionless. Moving on to conversion of units. So we all know that a physical quantity, which I told you earlier, is represented as numerical value into its unit. So here what will be used is n1 u1 is equals to n2 u2. You'll understand this shortly. Let's say we need to convert 1 Newton into dyne. Okay, so what we do is, let's say n1, the numerical value given here is 1, and u1, this being a force, will have the dimensions m1 l1 t minus 2. Let's say this as 1 1 1. Talking about dyne, n2, which we need to find, and u2, let's take as m21 l21 t2 minus 2. Okay, so m1, this being an SI unit, will have 1 kg, l1 is 1 meter, and t1 is 1 second. This being your series, m2 1 gram, l2 1 centimeter, and t2 1 second. Now we'll use this n1 u1 is equals to n2 u2. So n1 u1 is equals to N2 U2. Okay, so here the value of N2 would be M1 by M2 raised to 1, L1 by L2 raised to 1, and T1 by T2 raised to minus 2. Now putting all the values over here which we wrote previously. Okay, so M1 being a 1 kg can be represented or written as 1000 grams upon 1 gram raised to 1. L1, which is 1 meter, can be written as 100 centimeters upon 1 centimeter, and both being seconds will get cancelled out. So gram, gram, and centimeter, centimeter. So you get 1000 into 100, which is 10 to the power 5. Hence, 1 Newton is equals to 10 to the power 5 dyne. Summarizing everything on this slide, we saw about dimensional analysis, which is basically powers raised to fundamental units. We saw some examples. Then we saw about principle of homogeneity, which states that similar physical quantities can be added or subtracted. We saw an example on it. And then we saw some expressions which do not have any dimension, like anything raised to its power or anything enclosed in log or any angle. And last, we saw conversion of units with a beautiful example of 1 Newton being converted into dyne, and the final conclusion being 1 Newton is equals to 10 to the power 5 dyne. This is your last slide of this video, which is vernier caliper and your screw gauge. Okay, so starting with vernier caliper, if you see, there are two scales, the one being your main scale and the other being your vernier scale. Okay, these are basically used to measure things accurately. Okay, starting with your least count. So how do you define least count? Least count is basically the smallest measurement an instrument can measure. It is basically the smallest measurement of an instrument. Okay, it's basically written as 1 MSD minus 1 VSD, where MSD stands for main scale division and VSD stands for vernier scale divisions. Okay, so usually how the question is asked is that you are given the main scale division and you need to find out vernier scale division, and hence will come out in finding the least count. Okay, so what would they give in the question is, let's say they say n vernier scale divisions coincide with m main scale divisions. So from here we'll find out 1 VSD would be equal to m by n times MSD. Okay, so let me explain you with an example. Okay, let's say they say a vernier scale or a vernier caliper. A vernier caliper has 1 millimeter marks on the main scale. It has 20 equal divisions on the vernier scale, which matches with which matches with 16 main scale divisions, and they ask you find its least count. Okay, so here vernier caliper has 1 millimeter marks on the main scale. So this is basically your MSD, and we need to find out VSD. I told you earlier how do you find. You just equate the number of vernier scale divisions into VSD with number of main scale divisions into MSD. So they say 20 equal divisions on the vernier scale. It is 20 VSD is equals to 16 MSD. So 1 VSD will be equal to 16 by 20 MSD or 4 by 5 MSD. So your least count would be 1 MSD minus 4 by 5 MSD. That is basically your 1/5 of 1 millimeter, which is 0.2 millimeter. This is all about least count. Now if you talk about readings on a vernier scale, so your observed reading would be equal to your main scale reading plus your vernier scale reading. The mean scale reading is usually given in the question, and the vernier scale reading is basically your least count into the coinciding division of the vernier scale. So least count multiplies the division of the vernier scale, which is coinciding with the main scale. Okay, already the video is very lengthy, so I'll take questions on vernier caliper and your screw gauge in the next part of the video, which will be basically all questions. Okay, so sorry for that. I'll have to move on to next, which is a zero error, where you have positive zero error and negative zero error. So when is positive zero error? So positive zero error is when, let's say this is your main scale having a 0 mark over here, and here is your vernier scale having a 0 mark over here. So when you close both the jaws, okay, when you close both the jaws, if the 0 of the vernier scale is lying to the right side of the main scale, then it will be considered as a positive zero error, and a negative zero error when the 0 of the vernier scale would be on the left of that of the main scale. As shown in the diagram, you can see 0 here on the vernier scale is to the right of the main scale, and the 0 over here in the negative zero error is to the left of that of the main scale. Okay, so for the zero error, okay, so here for the reading, the correct reading would be equal to the observed reading minus zero error. Okay, here zero error is basically your least count multiplied by the coinciding division, and for negative zero error is minus of least count multiplied by, let's say there are 10 divisions, so 10 minus the coinciding division. Okay, don't worry, I'll take questions in the next session. Moving on to our next instrument, which is your screw gauge. So has two scales. Okay, as we saw in vernier caliper, we have a main scale and a vernier scale. Here you also have two scale, which is your pitch scale and the other being your circular scale. As you can see over here, this is your main scale, it is also called a sleeve. Okay, and the other, which is this, being your circular scale. It usually has 50 divisions, or many times it can also be 100. Okay, so pitch, if you want to define pitch, so pitch is basically the distance moved between two consecutive threads, or basically the distance moved by a screw due to one complete rotation. Okay, so pitch is basically the distance moved by a screw due to one complete rotation. About least count, the least count is pitch upon number of circular divisions. So pitch upon the number of divisions which are present on your circular scale. Okay, observed reading would be equal to the main scale reading, which is basically the reading on the main scale over here, and your circular scale reading, which is basically your least count into the coinciding division. So which coinciding division is basically, as you can see, this is your main scale, and the division which coincides with this main scale would be your coinciding division. Okay, moving on to zero errors. This is an example of a zero error, where you can see the 0 of the main scale is coinciding with the 0 of the circular scale. This is a positive zero error, and this is a negative zero error. Positive zero error when the 0 of the circular scale is below that of the main scale, and negative zero error when 0 of the circular scale is above that of the mean scale. Okay, so yeah, same thing. Positive zero error is your least count multiplied by coinciding division, and negative zero error is your least count multiplied by, assume let's say 100, minus the coinciding division. Okay, summarizing this slide, we saw two types of instrument. One is a vernier caliper and second being a screw gauge. In vernier caliper we saw about least count and how do you find the observed reading, and we even talked about the zero errors. Second instrument, which is a screw gauge, we saw about how to find the least count, the observed reading, and we saw about your zero errors. And that's it for today's video. I hope this explanation helped you understand the concept better. If you found this useful, don't forget to like, share and subscribe for more such videos. Thanks for watching, and I'll see you in the next one. Thank you guys.